Something incredible has happened at the CERN particle accelerator. What the researchers have discovered there could truly turn our understanding of physics upside down and perhaps even pave the way for warp drives in all Star Trek dimensions. Buckle up and get ready for a journey into the world of particle physics. Welcome, everyone.
Hi guys, before the video starts, a quick note, it's my birthday today, so I am turning 33 years old, 33 trips around the sun, and yes, what do I wish for my birthday?
Actually, my biggest wish this year is to crack the 100,000 subscribers here on YouTube.
If you haven't subscribed yet, and if you have friends, siblings-in-law, or anyone else you know who hasn't subscribed, then please help me reach this goal. I would be very happy about that. Otherwise, I look forward to another round of sunshine with you. And now, let's get started with the video.
So what's it about? At CERN, the European Center for Particle Physics, scientists have observed an extremely rare event, so rare that it occurs only 13 times in 100 billion cases. Imagine that. It's like finding a needle in a haystack. Only the haystack is as large as an entire galaxy. But what exactly did the researchers see there? It concerns the decay of a charged Kaon into a charged pion and a neutrino-antineutrino pair. I know it sounds like a few neurons in my brain are miswired, but don't worry. We will unravel this step by step. First of all, what are kaons anyway? Kaons, also called K-mesons, are strange particles, not strange in the sense of weird, but in the physical sense. They contain a so-called strange quark. Quarks are the building blocks of protons and neutrons. Normally these consist of up and down quarks, but kaons are special. They contain an up quark and an anti-strange quark. Now you might be wondering, AstroTim, what the heck is an anti-strange quark? It's basically the evil twin of the strange quark. Or maybe the good twin, depending on which side of the force you stand on. In any case, these kaons are particularly interesting to physicists because their decay is very accurately predicted by the standard model of particle physics. The standard model is, so to speak, the basic framework of particle physics. It describes all known elementary particles and their interactions. It is a bit like a construction manual, and just like the instructions for dubious products you've ordered from Wish, it has a few blank spots that scientists would like to fill. Professor Mark Thompson, chair of the Science and Technology Facilities Council and contributor to the new CERN experiment, says, "The standard model describes the fundamental forces and building blocks of the universe. It is a very successful theory, but there are several mysteries of the universe that the standard model does not explain, such as the nature of dark matter and the origins of the imbalance between matter and antimatter in the universe, and this is precisely where our super rare event comes into play. According to the standard model, less than 1 in 10 billion charged kaons should decay into a charged pion and a neutrino-antineutrino pair. That sounds pretty rare already, but wait, it gets even crazier. To observe this rare decay, scientists at CERN conducted the NA62 experiment. They shot a high-energy proton beam at a stationary target. It was a bit like shooting a water pistol at a buddy who wasn't moving. It's just that the water gun would vaporize the buddy in this case. Ah yes, the beautiful memories of the summer holidays back then. During this collision, secondary particles are created. These are measured by the detectors and can be identified, and here it comes. After years of research and millions of collisions, scientists have actually found evidence of this super rare decay. But here's where it gets really exciting. The decay occurs more frequently than predicted by the standard model. Instead of occurring less than 1 in 10 billion times, it happens about 13 times in 100 billion times. This may not sound like a big difference at first glance, but in the world of particle physics, it is absolutely gigantic. Professor Christina Lazzaroni from the University of Birmingham is certainly thrilled. With this measurement, the kaon decay appears to be the rarest decay established at the discovery level, the famous 5 sigma. This difficult analysis is the result of excellent teamwork, and I'm extremely proud of this new result. 5 sigma. At first glance, it sounds like the name of a K-pop band, but in science, it means that the chance of this result being a statistical coincidence is only 0.006%. In other words, it is almost certain that something absolutely crazy is happening here and that we do not have a measurement error. But what does that mean now? That is the million-dollar question, or perhaps rather the billion-euro question, considering how much of our tax money goes into particle physics research. It could mean that there are new particles that we have not yet discovered, or it could point to completely new physical laws that go beyond our current understanding. Professor Giuseppe Ruggiero from the University of Florence sums it up this way: "This is the culmination of a long project that began more than a decade ago. After a thorough and painstaking job, we have received an amazing reward for our efforts and delivered a long-awaited result." Imagine working on a puzzle for years. And when you finally place the last piece, it suddenly doesn't fit. This is roughly the situation that particle physicists find themselves in now. They have a puzzle, the Standard Model, which has explained everything so far, and now they have found a particle that does not fit in. What could this mean? Well, it means that we need to completely change the rules of the puzzle. This could be the first hint of a completely new physics. Perhaps there are forces or particles that we didn't know about before, or maybe we have to rethink our understanding of space and time. Who knows? Maybe this is even the first step towards discovering new dimensions. But before we go too far out on a limb, the scientists at CERN are cautiously optimistic. They know that they still have to carry out many more experiments to be sure that what they are seeing is really new. It could still be that there is an explanation within the Standard Model that we have overlooked. So it's a bit like we accidentally ignored the last paragraph of the puzzle instructions. I can already hear some of you saying, yes, but what does that mean for me? What do I care about kaons and pions? At first glance, not much. It is unlikely that the laws of physics will suddenly change in our daily lives tomorrow. You won't suddenly be able to walk through walls or travel back in time, although that would be pretty cool. But in the long run, this discovery could change our entire understanding of the universe. Perhaps it will lead us to new technologies that we cannot even imagine today. Who knows, maybe this is the first step towards developing warp drive. Captain Picard would be delighted in any case. One thing is for sure, the scientists at CERN will have their hands full in the years to come. They will conduct further experiments, collect more data, and try to solve this mystery. And who knows, maybe we are at the beginning of a new era in physics. I will keep you updated on further developments. If my kaons do not decay beforehand, feel free to subscribe to the channel now. And while the researchers at CERN are feverishly working to solve the puzzles of particle physics, revolutionary developments are also occurring in other areas of science, specifically in lunar research. The moon, our constant companion, could soon become the next big playground for groundbreaking discoveries. And to discuss exactly that, I have a very special interview for you with German ESA astronaut Matthias Maurer. He was part of the mission to the International Space Station and is now bringing a breath of fresh air to research on our Earth satellite. What does this mean for future moon missions? And could we perhaps soon see a permanent human presence on the moon? Make sure to click on the top right to watch the super exciting interview. It was truly one of the most thrilling encounters of my life. So everyone, click away. And if you want to support me beyond that, feel free to click on older videos as well. Every click helps the channel a lot. Otherwise, I'd say see you in the next video. Take care, folks.